Part 2, fever dreams. So this is, I believe the date is 1854. And it's a young man, and let me show you a picture of the young man. He's been exploring the jungles in Malaya, what we would call Indonesia today. And he's probably been bitten by an Anopheles mosquito, which carries the plasmodium, which causes malaria. And malaria breeds in the red blood cells. It makes them burst. It makes you basically instantly anemic, plus all the products, the necrotic products of dead blood cells build up in your bloodstream, and it just makes you very sick. And so he's got the feverish delirium of someone who's having an attack of malaria. Now, malaria, of course, has been a plague on humanity for 5,000 years. The Sumerians were bitching about malaria. The Egyptians were bitching about malaria. The Romans were always complaining about malaria. And in fact, real estate prices in ancient Rome were based on how far you were away from the river, because the river was the malarial cesspool. The Venetians had trouble with malaria. And of course, the British in India and Malaya, and this young man is British, had horrible problems with malaria. The Singaporeans had trouble with malaria until the middle of the 20th century, when they said, you know what, let's drain all the swamps. We'll clean this place up. And all of a sudden, Singapore, in the torrid zone, in the malaria zone, they don't have any malaria anymore. But that's getting ahead of ourselves. Let's go back to 1854-ish, where this young man is on a bed, thin bed, deep in the jungle, sweating his guts out. I haven't told you. It's called drama. And he's having his fevered thoughts. And he's in Malaya because he's a zoologist. And as Terence McKenna would do a century later, he's collecting butterflies and plant specimens and all sorts of crazy stuff. And he's looking to identify new species of animals, because this is the Victorian era. And the classification of everything is the biggest concern these days. And he's already seen something very, very, very odd. In the Indonesian chain, there are two islands, Lombok and Bali. Bali is next to Java, which is the big island that has Jakarta, separated by about 15 miles to Bali, separated by about 15 miles to Lombok. Now, Bali and Lombok, not far apart. You know, it's like less than an hour in the ferry. And for some reason, the plants and the animals on Lombok are completely different from the plants and animals on Bali. Whereas the plants and animals on Bali are almost exactly like the plants and animals that are on Java. These islands are the same distance apart. He can't make any sense of it. And as he's been traveling around, he's starting to see that, in fact, there's this, the only way he can think of it is this dividing line in the middle of the Indonesian Sea. And everything on the east side of this line, which includes Lombok, looks like plants and animals that you find in Australia and New Guinea. And everything on the left side looks like plants and animals that you find in Asia. And he can't explain it, and no one will be able to explain it for another 100 years until they invent plate tectonics and they figure out that the Indo-Australian plate has been careening through Indonesia into the Eurasian plate at an enormous rate of speed. So even if you set the clock back 100,000 years, Lombok and Bali were much further apart, much further than plants and animals could reasonably be expected to migrate. But that line across the sea has been given the name of its discoverer. That line is called the Wallace Line. See, there's Lombok and Bali right down there. See how close they are together? Named after the discoverer, Alfred Russel Wallace. So, and there's Wallace again. Wallace has spent the last several months, see, there we go, doing little but looking at the great variety of life in this corner of the world, just basically island hopping. He boarded a boat for home in 1854 with all of his samples that he'd spent the last 3 years collecting. It caught fire. All of his samples went to the bottom of the sea. He spent 10 days in an open boat with the other crewmates before he was rescued. But this is before that happens. He hasn't gotten the final disappointment yet. But he does have malaria, so he's not really happy. And he's got a fever of maybe 105 and 106, and so he's delirious. You know what that means. He's absolutely delirious. And so because this has been running through his mind, he sees the forms that he's been observing in nature and documenting one after another. They're just coming at him and coming at him and coming at him. And one is morphing into another. And so you have buds and leaves and flowers and beaks and crests. And he keeps on asking himself a question that was a consuming passion at this point. Why are there so many different forms? What the heck's going on here? Is nature just crazy, just tossing out form after form after form, each of them just a little bit different? What could this difference possibly mean, one form to another? And somewhere in his delirium, he starts to understand that just a little bit of a difference might make it easier to evade a predator or to catch prey or to camouflage yourself or to burrow in a tree. And even if that's just a little bit of difference, after a generation, well, then all the children of that plant or that animal will carry that difference along. And if that's just a little bit of a difference, as it builds up in the geometric progression, one after generation after another, that little difference can eventually geometrically, and remember, Thomas Malthus has been writing about geometry and population, and how populations always grow geometrically. And this is running as an undercurrent through the entire Victorian era, so that's very much on his mind. So he sees the geometric growth of populations with small changes, and all of a sudden, he realizes that it just takes a small difference in how one species will prosper relative to another. And all of a sudden, you see the complete replacement of the old model by the new improved version. And that's what Wallace conceived of. That process we now know today as natural selection. And he realized this was the big one. This was the answer to the question that everyone in biology had been asking for over 100 years. He could explain the hitherto unexplainable origin of the species. Of course, solving that problem presented new ones. Even in the high Victorian era, with industrialization and urbanization and education all approaching levels that we would think of as reasonably modern, the Church of England, which is arguably, other than the Crown, the most powerful influence in the Victorian era, declared that all species originated at creation from the act of God, that all species with all of their variations were specifically the act of God. And that was it. No argument, no question. That was what the Bible said. Nothing natural about these forms. Now, for an idea to succeed out there in the world, a true idea, let's say, like gravity, or Esperanto, or natural selection, it has to fight its way tooth and claw into the ecology of our minds. And there are powerful forces that exert selection pressures on all ideas. And this has been, I think, a constant theme that's been running through the conference so far. For example, if someone came into this room right now and challenged all of your deeply held ideas about the creative or sacramental use of substances, all right, there would be an enormous selection pressure coming from all corners in this room. This room might develop into factions, different arguments would be tried out, they'd throw them at this person would have to then either defend his ideas or submit to your ideas, so on and so forth, and there would be a very rapid-fire evolution of all of the ideas in this room because someone was coming in and really saying, no, it's this way. It's not that way. It's this way. But of course, if this person is a Nobel Prize winner, well, you're going to listen to him. You're going to give him a little space because